Hello, this is Math Models. On topic 2-3, we're going to be talking about real-world graphs and matching descriptions to a graph. Now here's some things that you need to think about. What's your dependent variable? What's your independent variable? And I want you to remember that y depends on x. Alright? Now is it increasing or decreasing? Increasing means that it rises to the right. Decreasing means that it falls to the right. So we have going up and we have going down. And then y-intercept and x-intercept. Okay? Y-intercept, this is the y-axis, this is the x-axis. Does your graph hit this line? Does it make sense? Does your graph hit this line? Where would it, and does it make sense for it to actually hit that line? So let's go ahead and take a look. Here we take a roast beef from the refrigerator and put it in the hot oven. And the temperature of the beef depends on how long it has been in the oven. So this means that my temperature is my y and how long has it been x. So I'm going to call this time. I'm going to call this temperature. Now I don't have any variables, so we don't need a scale. So my y-intercept is when I take it out of the fridge. Okay? And it's going to increase, and then eventually it's going to level off as it reaches the oven temp. Alright? And then eventually I take it out of the oven. Alright? Now, temperature of the fridge is here. Temperature of the oven is here. And my roast will warm up until it hits the temperature of the oven. And then I'm going to take it out. Actually, this could go on forever because we don't know when we're going to take it out. Let's go ahead and take a look at another example. Here, we're going home from the football game. And the time and speed. Well, this is one of the rare instances where time goes on the side, because the time it takes depends on how fast you drive. Alright, so this will be time, and this will be speed. Alright, now, does it make sense for time to be, for my speed to be 0? Well, I will never get home if my speed is 0. So I'm going to start somewhere around here. Now, can my time ever be 0? Okay? Can I ever instantly be home from the football game? Alright. And so that means my graph is going to go somewhere along that. Well, this is my minimum speed. This is my max speed. Well, the minimum speed obviously takes the most time, and the max speed takes the least amount of time. But it does not make sense for me to have any kind of x or y intercept here. Let's go ahead and take a look at example number 3. Alright, so the price of a pizza depends on the diameter. Well, that makes it really easy. That's my diameter. This is my price. Well, the smallest pizza I can possibly think of is like a 4-inch pizza. Okay? And you're talking about a little pizza that fits in your hand. And really, the oven has a maximum size. We have a maximum size oven. Alright, and let's just say that that is, a 32-inch pizza. Alright? Now, what do you think is going to be more expensive, the 4-inch or the 32? Well, the 32-inch is definitely going to be more expensive. And the 4-inch, we're still going to pay for it. The 4-inch is not going to be free. So we're looking there. And then our graph, will probably look something like that. All right, the bigger our pizza, the more it's going to cost. All right. Again, it doesn't make sense for our pizza to have no diameter or our pizza to be free. And so that is our examples for this. Okay? All we're doing is looking at our data and seeing if we can make a reliable table. Now, I'm not asking you to put all the little notes that I put on there, but there are some things that are very important. I need your labels, and I need your graph. All the rest of it is really kind of optional, so long as you can explain why you've drawn your line the way you have. Good luck on your assignment, and have a good day.